An irregular hexagon with all sides of equal length is placed inside a square of side length 1, as shown below, not to scale. What is the length of one of the hexagon's sides? Okay, so I will sketch the picture of this hexagon. So we start with a square of side length 1. And then a hexagon is drawn. Let me just draw these two. So there's the hexagon. It's not a regular hexagon, of course, where all the angles are equal. But the side lengths of this hexagon are the same. Let's call that x. And the side length of the whole square is 1. So that, of course, means that this is 1 minus x. This, of course, will also be 1 minus x. And this is x. And the additional piece of information we need to solve this is that this here is equal to x. So now what we can do is we can apply the Pythagorean theorem on one of these triangles. We see that x squared is equal to 1 minus x squared plus 1 minus x squared. And I'd like to use this equation to simply solve for x. So I don't think this is going to factor, but we'll just use the quadratic formula. Okay, and based on the geometry of the problem, we obviously need x to be between 0 and 1, and so we have to take the negative sign here. Root 2 is about 1.4, so I know that this is between 0 and 1, and I hope this is one of the options that's given. 2 minus root 2, it is, that's option B. So pretty confident in this. I mean, I thought for some reason going into this, maybe there was going to be some trigonometry or something like that, but of course everything is either right angles or 45 degrees, so we could get around that. And the key is really the piece of information that the hexagon has all of its sides of equal length. So knowing that this side length here is x, and knowing that these two side lengths are both 1 minus x allows us to figure this out pretty easily. Don't have much more to say about this one, but if I think of anything, I'll put it down in the description. Thanks for watching.